First, thanks to the committee for the opportunity to present today. I'm going to talk to you a little bit about some of the stream channel maintenance practices we've looked at over the last 5 years. Really, a lot of the heavy lifting's been done by the project team, Dan Mecklenburg, who works with me at Ohio State University, Holly Aryan Hall, who you might have seen her presentation earlier, worked for EMH&T, but she actually got the project started off when she was a hydraulic engineer with the Ohio Department of Transportation, Miles Hebert and others. In the early phases of the project, Peggy Johnson from Penn State worked with us, and really all of the important contributions from probably more than 150 or 200 people at the Ohio Department of Transportation that were involved in various aspects of the research. So some of the issues and research questions that we tried to address, Holly and others at ODOT noticed that some of their channel maintenance practices set off this maintenance cycle where they'd go out and address an issue, but they were coming back to address a scour or sedimentation aggradation issue, and that was just a repetitive sort of thing. So some of the practices that they were using seemed to be costly, maybe ineffective, or only temporary solutions to the issues they were having. So we were asked, can we find some alternative practices that are appropriate for this geographic region? Are they implementable? One of the caveats is that the ODOT forces wanted to implement some of these solutions. So did they have the skilled labor, the ability to design? Can they acquire the materials? And did they have the right equipment to place some of those materials? So we wanted to make sure that the practices we were selecting could be implemented by them. And then if we did find some solutions that seemed to work, could we help ODOT build capacity to do this more regularly? If you go to the ODOT Bridge Maintenance Manual, you'll see some of the photos are a little bit old, but the problems they had probably back in the 1970s or 80s, looking at the dress they have there, they're still the problems that they have today. Channel incision, whether that's caused by land use change and a change in watershed hydrology, or whether it's contraction of flows and local scour, they still have to deal with channel incision. Debris accumulation is an issue, particularly where you have mid-channel piers. And then probably their two most common problems, the stream bank migration. Streams like to move around in certain situations, whereas bridges do not. So as the lateral migration, particularly if there's high migration rates and you have a long design life on the structure, that's likely to cause a problem, eroding embankments around the wing walls. So that's an issue they deal with a lot, as well as bed aggradation, where you either have low energy streams or you have an energy that's low sloping or low energy relative to the contributing reach above it. So those are some of the very common problems that they deal with. The solutions to those in their manual, for the incision, it's your grade control, whether that be sheet piling or perhaps grade control riffles. The debris accumulations, that would be either going down in that environment, cutting up the logs and hoping they float away in the next storm, or perhaps mechanically removing those with grapple hooks from the bridge roadway, or from actually this brave employee here that drove the excavator out to remove some of those. I hope they got hazard pay that day. For the channel migration, the typical solution is armoring with rock channel protection. Can be very effective if done well. I've seen a lot that have failed, but this sort of solution doesn't provide a lot of environmental benefit either. So are there other solutions we can use to address stream bank migration? And then a very common one in many parts of Ohio, that dredging or dipping. You have the aggradation, the sedimentation, so you dredge or dip or clean or whatever the terminology you like to use, and all that does is a lot of times is simply reset that maintenance clock. It's just a matter of how long will it be before you are out there again doing that same sort of activity. Early on in the project, we wanted to understand what their goals were, all the way from people in the state offices to the district to the local county crews. We met with all of them, tried to understand their goals, but what limitations did they have in terms of equipment and skilled labor and materials they could acquire. And we found early on they really wanted to reduce those long-term maintenance needs. They have plenty of work to do, whether it's replacing culverts or working on structures. If they could come up with some practices that reduce that long-term maintenance need, that would be a great thing. partially because it was environmentally sound. We didn't just hear that from the Office of Environmental Services. All across ODOT, we heard we didn't want to be impacting streams. We want to protect those water resources that we're in charge of, that our structures go over. And are there ways we can improve the habitat and protect the biota as a result? We found early on that these solutions needed to be simple and economical. There were times we proposed fairly extensive projects that were expensive, might take multiple weeks, crews of 4 to 8 people, and that, in their world, that just wasn't viable. They needed to be shorter projects, crews of 2 to 4 people, 1 to 5 days, and they have an account limit. There's a threshold which they can't exceed that would make it challenging to do some of these projects. So that limit was 60,000, but we were told if we could get projects down much lower, that would be very, very beneficial for their budgets. And like I said, at times it was a compromise between what we really wanted to do. Other things like available right-of-way drove our designs at times, and we communicated that certain designs would be more resilient to failure than others, and that was just a trade-off that we talked about before we ended up with the final design solution. And then, like I said, we wanted these to be readily implementable by those county crews who often they were experienced operators working in the field, but not necessarily in this environment. The project team had a lot of background in channel design, stream restoration, but we went ahead and looked at all the literature that was out there from organizations and the peer-reviewed literature. And then we brought all the solutions that we thought might be viable to the ODOT, to the folks at ODOT, and we pared that down to a handful of practices, which I'm going to show you a handful of the outcomes from that. Real quickly, I want to show you the main problems we typically have. In column A, you've got the plan view here, and this is how a lot of crossings would be designed. So you have sections A, which would be upstream, so you have a narrow stream channel and deep. And then as we transition to the opening, we need to pass a large design flow, 10, 50, 100 years, so that gets much wider, which you can see in B and C. The stream's response to that is often one of B or C. So the first one would be, there would be starting to be a deposition of a bar, which would often vegetate, and then initiate that meander migration, which might then impact the embankment. And here's an example of that here. When originally constructed, you see the narrow stream channel, a bar deposited, and now the alignment is poor. It's actually eating away at the embankment outside of the wing wall there. Another response we often see, depending upon the energy of the stream, water levels, that sort of thing, might be uniform aggradation, and that's what instigates that dredging, that dipping, or that cleaning. So some of what I'm going to show you is going to address 2 of those primary problems we see consistently in Ohio. And there's an example of that uniform aggradation, impacts the capacity of the opening of that structure, and instigates that maintenance activity. So the first type is this Bankfull channel design. Holly talked about earlier, that compound channel. So rather than widening out, let's keep that compound channel form. So just very simple, took about a simple project, took about, let me do one thing here. What's that? No, it's, I have a video playing, but it's not. I have a short video here. Let me see if I can. All right, here we go. I think we might have it figured out. Sorry about that. Okay, so here we had a structure that was flooding more frequently than it should have, And the fact that it became a little bit incised, it was causing some erosion on the downstream end that the landowner was complaining about. So what we did is we simply lowered that floodplain. We wanted to go ahead and keep a compound channel form so we had control over where the alignment of that flow. It wasn't great in this particular case. In most cases, we'd like that inset channel or the bottom part of that compound channel centered. We didn't do that here. It's a little bit easier to permit. You're not disturbing that stream environment. So simply by lowering that floodplain, we're able to gain capacity, keep that compound channel form, and in the upper left, you'll see that reduced the shear stresses downstream and actually allowed that bank to vegetate and stabilize. Like I said, we might use that rather than creating that big wide opening through the span to try and keep that compound channel form with the inset channel centered so we have good alignment in that case. We're not getting into wing walls or piers if they're there. So that's a very simple Bankfull channel design or a compound channel. The second practice I want to share is a single arm vane. This is in Wayne County. You can see the narrow stream. This is about how wide it is upstream, but when this bridge was constructed, it was open to both spans. And what the channel's done over time, it's narrowed up, and as this bar developed, it's pushed it into the wing wall. That's been rip-wrapped twice. It was grouted a third time, and that was starting to fail as well. So is there a different practice we could use in this case? And what we used was this single arm vane. There, we're working now. So you can see the narrow channel upstream. It was widened. Nature's narrowed itself, but migrated over into the wing wall, so it's got poor alignment. What we wanted to do, we wanted to increase the capacity. We may not be back to the original design capacity, but we definitely improved over the current situation. One span was roughly the width of the channel, so we opened that up. And then we use these V-lock interlocking blocks as an alternative to quarried rock. A lot of times in the stream restoration industry, you'll use large quarried rock to create these structures. The folks at the county offices said, hey, we have these blocks. They're very easy to move. They're very cheap. They're very structurally sound. Can we use those? So we were able to use those in the project after checking through. Calculated a maximum depth of scour. We placed some footer blocks. This vane comes off of the stream bank at a 20 to 30 degree angle. At the downstream end, it's the height of it, the finish height is approximately at the Bankfull elevation, so the depth of channel nature would like to create. And then the slope decreases downstream at roughly 7 degree angle until it intersects with the stream bed. This particular one, when they started building the structure from start to finish, from starting to dig the footers, was about 4 hours. So very efficient way to move material, very simple digging. What happens is the water flows into the stream here as it encounters that, essentially that vane, it's redirected and centered. Early on, we had a little bit of erosion before vegetation was established, but no problem. We had gravel go in and fill that space. Now we have a much better aligned channel. You can see right after there's a bar. When we had poor alignment, a bar underneath and downstream had formed. But when we had better alignment, that actually scoured that bar and increased capacity through that particular reach. And there you can see the flows being, this is a low flow, but you can see it's being redirected and centered under that span to help maintain that alignment. When you put two single arm vanes together, you get a cross vane. At this particular site in Ashland County, We had a very steep watershed above it, very narrow ravines, and then downstream of here we had a large river, so a flat, large river floodplain, and all that sediment would drop out, and we lost capacity underneath this bridge. And virtually every time there was a significant rain, they would have to close the road due to flooding. This is going to be a continuing maintenance problem probably over the years, but we've got it to the point where they're not having to go out and close the road every time. So what we wanted to do is use these two veins to center and concentrate the flow so we can keep sediment moving through that opening. Constant removal of debris from that area. Looks like the excavator's doing a few calisthenics, warming up. And so they're simply excavating down to that maximum depth of scour to set those footer blocks. Both of these veins come off 20 to 30 degree angle at roughly a 7-degree decline in the upstream direction. Once again, using those interlocking V blocks, 2x2x6 concrete, nice handy dandy handle to move them around. They weigh about 3,500 pounds apiece, probably structurally superior to a regular quarried rock. In this case, there were 3 layers. These guys really got after it. And there they're placing the last layer. Block in the bottom to help keep it from undermining itself so there's not scour to smoothly transition that flow a little more. And here are some skeptical county workers at the beginning, seeming to have actually enjoyed their work, so that was great. So there's the solution. And there was one time debris clogged that and had to be removed. A little bit of maintenance, but you can see how well it concentrated flow. Here's the downstream end. It actually had some bioengineering components and a little bit of reshaping of the channel. Probably in hindsight, we might have done some rock channel protection there due to the nature of the soils, but definitely they don't have to close that road. And in fact, I know after 2 years, they hadn't had to close it a single time, so they were grateful for that and willing to undertake that project. If you put 2 cross veins together, you'll have a W-Weir, and this can be very beneficial for diverting debris from a mid-channel pier. Really, the most important components in this are the inner 2 veins on the W. Here we would, in the audience, we'd be standing at the approximate location of the pier, so you can see it's elevated, the water's flowing this way, and the idea is that as higher flows go, they'll divert that flow into the center of the spans, and I'll show you a high flow picture here at the end. Once again, with this W-Weir, we wanting to work in the dry, flow was diverted to one side, we worked as much in the dry as we could, and you can see there's kind of the nose, the center part of that W. Same design sort of criteria as we've used for the other veins. This was challenging. This was a 200 square mile watershed with a sand bed. So we felt if we could, and you can see here where it's diverting, you can see the bubbles split, the higher flow velocities. Typically they went out multiple times per year to remove debris accumulations. To my knowledge, they haven't been out there a single time in probably 3+ years. So they were very happy with the outcome of that project. Fortunately, that was a more expensive, more involved sort of project. And then the last practice I want to show you is where we're diverting flow into one culvert when you have multiple culverts. The county folks hate to have to clean those out, don't go in and do culvert cleanings. One of the designs that's been, that's caught on in some places is more this multi-stage culvert design. So how can we keep the sediment flowing, but we have capacity at the higher elevation, so we wanted to block off. We thought this was a great idea, and then my colleague Dan was in Minnesota and he realized somebody already had tried this out. But my last slide here, here's the example of this twin box culvert weir that we've trialed out and seems to be working pretty well so far. You can see the width of the stream upstream is about 3 feet wide. Each of the boxes was a little bit wider than that. They would have come out to clean out the apron otherwise, in this case. But in addition to that, we've had them go ahead and place those interlocking blocks. In this particular instance, normally they would have gone in and tried to clean the culvert itself. We asked them not to do that. We were hoping once we diverted the low and intermediate flows into a single box, that would clear the sediment in there. And then when we got a high flow, that would be at an increased slope so that it would scour any sediment out of the other side. And as of our last visit, that seems to be the case. So they were quite happy they didn't have to clean the culvert. Fairly simple sort of solution. And it's these ones we think, we've done 15 pilot projects. We think the single arm vanes are going to be fairly cheap in the $2,000 to $10,000 range, going to take anywhere from half a day to 4 days. And then those culvert weirs that we showed you are going to be more in the order of $1.5K to $4K, take anywhere from half a day to a day. And some of the larger projects are probably not appropriate for undertaking regularly without experienced folks. So probably but there's lots of opportunities for this. We've developed some design tools, some educational materials that we'll share. And now, hopefully, ODOT has an expanded toolbox to deal with some of their stream channel maintenance. If I've gone over, I'm happy to answer. Okay. Yes, sir.
How many of the weirs have you done and for how long?
So we started back in 2013. We probably, I can't remember if it was early 2015, we put in the first, it was either end of 2014 or 15, we put in the first ones. And then we put in a couple a year up until last year. So there's been a few years on some of them.